are a few things you have to remember from trig. One is the unit circle. Most importantly, quadrant 1 of the unit circle. Because what we have to do with inverse trig is oftentimes find values from the unit circle. So being able to quickly identify, okay, root 3 over 2 for cosine is pi 6. Good, got it, great. And then knowing all students take calc and knowing which quadrants represent which. This is negative pi from basically here. So what that means is to find the points in here, you take pi minus something with pi. Here you add your pi, and here it's 2 pi minus. So again, in order to figure out where these values lie, this is the little trick that you use to find them. So what that means is like this would be pi plus, let's say pi 6. And that would get you to 7 pi 6. To go backwards, it's pi minus, and then here it's always 2 pi minus. So again, this one is 11 pi 6 because it's 2 pi minus pi 6. So that's just the trick to help you figure out which is which. We don't really need the secant, cosecant, or cotangents. We have a tendency to focus on inverses using sine, cosine, and tangent. And typically the one that pops up on the AP test is arctan or arcsine. I've actually never seen an arc cosine, but I know the year will come that I say, I've never seen an arc cosine, and an arc cosine is going to happen.
You might not be happy either. Wednesday, he's going to hold us.
And we're going to probably have a test one day this week on this stuff.
Quiz, or we have our pit test on Wednesday, so we'll see.
That we're so prepared.
Hey, the one that he gave us when he wasn't here, I got a 44 out of 50.
Yeah, I did.
Outright or after?
No, before.
No, he put a 43 out of 50, and I did 3 problems. I
Oh,
did
is he
8,
high?
so I don't know how that makes sense.
No, because the ones you skipped were more. Did you say that?
I said high. I have like half of the thing today.
Okay, so I will start this section with a very, very bold statement that we have to talk about. None of the basic trigonometric functions have an inverse. And this relates back to the worksheet you did on Friday, where I had you talking about, okay, are the functions one-to-one? So a function can only have an inverse if it is one-to-one. And it is only 1-to-1 if for every x there is only one y, and for every y there is only one x.
So there's inverses on a certain point of the graph.
So exactly, for trigonometric functions, because they oscillate and they are not 1-to-1, because there are many y's for many x's since it goes around and around that unit circle forever, what we have to do is we have to limit the domain of the inverse and the domain of the original in order for that to occur. And that's kind of what that table and those graphs are representing. They are representing what I call like a segmented inverse. So what you're doing is you are picking a piece of the cycle to find an inverse for. So if you go back and you think about the sine, the period of sine is what? How long is one cycle of one regular sine function? 2 pi. Because it goes 0 up to 1, back down through 0, down to -1, and back up to 0. So what happens though is even just in one cycle of pi, how many times does this fail to be 1-to-1? Many, 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 many times, right? So if you look down at arc sine, or y equals the inverse sine, the domain has to become -1-to-1, so the heights are the range, so the domain is the range, so that still makes sense. However, the range goes from -pi halves to pi halves. So essentially what it's saying, wow, that was itty bitty. So essentially what it's saying is we're starting here and ending here so that there are no duplicates. And what you'll notice is that the only duplicates are really at 0, so we just don't kind of have to stress about them. So there is, well, I guess I lied. It's in the middle. There is your range from negative pi halves, so it's at the min to the max. Because this would be negative pi, and this is positive pi. So it's only from the min to the max.
Well,
And then you turn it on its side. Yep. Because it would have repetitive values here and
Yeah.
there.
so then the domain it only goes up to 1 and down to -1?
Yeah, because it goes from the max to the min. So that's why we have to cut it where we cut it. So I can't cut it from 0 to pi because it wouldn't hit. And I can't cut it, so I could cut it from pi halves to 3 pi halves. Like that would also work. But you have to cut it in between, or you have to cut it from the mins to the maxes. Cosine is a little easier because it starts at a max, goes through, and goes down. So cosine, you would go from 0 to pi because of the design and the nature of the function. Does that make sense? Are you trying to see it turned?
Yeah, like, cause it's like our numbers are flipped. Like, is that, or am I just reading it wrong? Like, it's showing the pi halves on the y, and then the one in all the numerical ones on the x.
Because it is flipped. These are the arcs. Those are the inverses. Those aren't the
Yes.
you're not, like, this is
Am
the
I
original.
Am I ahead for a sec, or like, I don't know what.
So no. Like, this is the original.
Yes.
And this goes from 0
Yes.
to pi.
Yes.
So what that means is the one you're looking at on your paper
Yes.
is its inverse. So if this point on the original is -1 pi, on the inverse it becomes pi -1. So if you go to that, do you
Yeah.
see how pi -1 is now that
Yeah.
point?
That makes sense.
Because you have to flip the domain in the range.
Thank you.
You're welcome. That's why I said, I was like, wait. What I'm drawing and what's on your paper don't match up for a reason.
Yeah.
These are the originals. Like, this is y equals cosine. This is y equals sine. The ones on your paper are the inverses. So what I essentially did is I gave you the segments of their graph that would make them true. So if you think about tangent usually has a range of -infinity to infinity. Now it has a domain of -infinity to infinity. And if you look, you take the arctan, you could turn your paper and make it look like you want it to look. Right? Like you can see it. Okay. What we're going to do now is spend a little bit of time on the back going through just some old trig ideas before we get to inverse. So it says evaluating inverse trig functions. So this is not derivatives. This is old school trig. So the question is, what is the arc sine of -pi half, or -1/2 rather? So you have to recall that in trig, arc sine could only live in 2 quadrants, quadrant 1 and quadrant 4. So any answer you give me for number A has to be from 1 or 4 only. Arc cosine can only live in 1 or 2. Arctangent is like arc sine. It can also only live in 1 and 4. No answers will ever come from quadrant 3. No answers will ever come from quadrant 3. And honestly, the first time I did this, I forgot that rule. That the inverses can only live in certain quadrants. Because it just had been so long since like I had taught them. And like I made my hand out and I was like, that's not right. So like because it doesn't fit the domain. So you know how like on the front page we talked about like the domain? And we talked about how sine only lives from -1 to 1, and then its range is negative pi halves to pi half. That's where this idea comes from. That they're strictly from certain quadrants. So, what degree is the sine 1/2? So what basic degree is sine 1/2? 30, 60, 45. Yeah, pi over 6, right? So 30 degrees or pi 6. So now, because it is negative, you have to go down pi 6. Exactly. So arc sine of -1/2 is 11 pi 6.
You also say negative pi 6?
You can. They're the same thing.
I didn't know you're allowed to.
You can.
Mr. Mannion didn't accept that. He didn't accept that version. He wanted a negative for one or more questions.
So it's the opposite, but it gets negative.
No, we put it as negative. You might be right. It was 330, and someone put negative 30.
They're the same thing. They live at the same house.
Might be a dumb question, but the 1/2, how does that relate to pi 6?
1/2 is the possible. So if I asked you for the sine of 11 pi 6, your answer is -1/2. So this is like, okay, I'm giving you the -1/2. I want to know the trig value. It's, yes, it means the
Also
inverse.
means inverse trig.
Yes. Like, this is the same as saying sine inverse of -1/2.
We're doing our calculators, we just plug in our number.
Yes, but these would be non-calculators.
So the next one shows 0.
No.
The next one shows
I was like, no.
Pi over 2.
Exactly.
My fault there.
No.
So this one is a calculator.
No. Remember, tangent is sine over cosine. So I need the sine over the cosine to have a final answer of √3/2. I mean, √3/1. So what that means is the sine needs to be √3/2, and the cosine needs to be 1/2. So at what angle? There you go. You know it?
Is it 60?
Yes. I had 5/3 on my paper, so I had to be like, wait. So yes, it would be at 60. And since it's positive, we know it's 60 and in quadrant 1. Because the 2's cancel out, so sine over cosine is tan, so you get √3/1. So you get 5/3 or 60. Yes, go ahead. Are you telling me the answer?
No,
The next one?
I wouldn't.
Okay. Just stretch it out. This would be a calculator. This one we don't have a trig unit circle point of 0.3. So go ahead, take out your calculator. Now, this is positive. Where is sine positive? Of the 2 quadrants it can live in. Yeah, so my answer better be in the first quadrant. No. Well, yes, your calculator needs to be in radians to get the radians.
Yes.
And what do you get?
30.465265 degrees.
30.
I don't know. That's what it says.
Oh, I have 0.3.
That's what I got.
Oh, yeah, my bad. I was probably good. That's what it said.
I was like, how did we get all the same numbers with like totally different?
Yeah,
Okay.
I was thinking I needed
Totally messed with me. So yes, you should get 0.3047. So it says find the exact value of each. Draw a picture to describe the situation. So we have the sine of the inverse tan of 3/4. So ignore the sine stuff, and you have the inverse tan of 3/4. So what that means, or how you can picture that, is like saying the inverse tan of 3/4 equals kind of x, right? Because it's the backwards of what we're thinking. So how do you get rid of an inverse tan? You take the tan. So this would be like saying 3/4 x, 3/4 equals the tangent of x. Now, if I asked you to draw that, that's your SOHCAHTOA, right? So like, yeah, I mean, this one's easy because it's a Pythagorean triple. But like the tangent of theta equals 3/4, which is opposite O over A, opposite over adjacent. So if I asked you to draw me a picture, oh, I should draw the other way. I'll draw it the right way. Here would be like quadrant 1. We're in quadrant 1 because they're both positive, and it's arc. So 3 is sine is height. 4 is cosine. So you find the hypotenuse using Pythagorean theorem. Pythagorean theorem would give you 5, because 3 squared plus 16 is 25, or yeah, it's 25. Square root by 5 is 5. So again, 3, 4, 5 triangles are easy. It's our Pythagorean triple. Don't even have to do Pythagorean theorem. This is kind of where the x is living. And I probably shouldn't pick x. I should pick theta because I have like x on the horizontal and y. So I don't really like that I did that. So now the question is, okay, the inverse tan of 3/4 is talking about this angle here. So then it's saying, okay, what is the sine of that angle? So sine is opposite over hypotenuse.
Just talking.
Just let them go.
So this answer is 3/5.
Just let me ramble.
Until you confuse the rest of my class.
Yes. They'll be fine.
So did everybody kind of see how I worked my way to that? The inverse sine of 1/3. So once again, this represents opposite over hypotenuse. So opposite and hypotenuse are both positive. So therefore we live in what quadrant?
Yes.
1. So you draw your triangle with respect to the first quadrant. I'm going to be appropriate this time and use theta instead of x.
Yeah.
Oh, shush. So it's 1 for opposite, 3 for hypotenuse. What am I missing? Yes, I'm missing the square root of 8. How did I get that? Pythagorean theorem. So it's the square root of 3 squared minus 1 squared, which is the square root of 8. Why do I need that? Well, secant is the inverse of cosine, so it would be exactly. Instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. So my answer would be 3 over root 8. Not allowed to have roots in the denominator, so you get 3 root 8 over 8. Just because that's the only way an answer would be. Yes.
Can we look at A? So
Sure.
the inverse tan of 3/4 technically is the same, is basically pi 6, correct? Or no?
It's a 30-degree angle, what are you saying?
Isn't the point of that is to figure out what the angle is?
So no, the point is to figure out what the sine of the angle is.
But that's what I mean. But isn't that angle the 6.
I don't know, do inverse tan of 3/4 on your calculator. I don't think it is. Like if you do inverse tan of 3/4, what do you get?
16435.
Okay, take pi divided by 6. They were the same. Those two decimals should be the same.
0.523.
Yeah, they're close, but not the same.
This is close to half.
Because a 30, 60, 90 triangle should have that relationship of root 3, 2, and 1. Like, dang it. Okay. So, a little bit. So this would be a 30, oh my gosh, 30, 60, 90, right? So in a 30, 60, 90 on the unit circle, the radius or hypotenuse is 1. The radius of the unit circle.
I was thinking the same.
So think about what is the sine of 30 degrees?
I don't know. 1/2.
Yeah, it's 1/2, right?
Yeah, but I thought the hypotenuse has to be 2. That's only 1.
You gotta watch. There's an x flowing into here somewhere. We're gonna have an x flow in.
Oh.
What is the sine of 60?
Square root of 2.
Okay, right? So this is opposite over hypotenuse, opposite over hypotenuse. So the relationship comes into
Wait, what?
play.
Opposite over hypotenuse, opposite over hypotenuse.
Yeah, because they're both sines. So this opposite is
Okay.
1, and we're going to put an x with it. This opposite is root 3. We're going to put an x with it. Think about the unit circle. We say that this is root 3 over 2. Okay, so that 2 right now we currently don't see here. So you're going to turn this into 2x. So a 30, 60, 90 has a 1x, root 3x, and 2x relationship with all their sides. So the way that I knew this was not a 30, 60, 90 is because you did not have a root 3 as part of your answer.
So you're able to just change the length of that hypotenuse and not anything else? That's just okay. Like you don't have to double the other ones too?
The reason these are divided by 2 is technically you divide all of these by 2 to make it the unit circle. That's why there's 2 over them.
Right?
You yelled at me because it's the unit circle and there's only one. That's why.
No. So like, the radius of the original triangle.
Oh, I understand.
Is
So x
1.
would be 1/2.
So, but in order to get a general 30, 60, 90, I wanted you to work off of that to this.
Okay.
This would be like outside the unit circle. Or anywhere.
Yes.
So now, your x would be 1/2 to be a unit circle. Think about this. This would then have a 1/2, and this would have a 1/2.
Oh,
So there would give you your 1/2, root 3 over 2, your 1.
Magic.
It is like magic. But like that's what I said, he put me on the spot. Like I haven't had to show this or think about that in a long time. But I always know there's a relation with the 1, the 2, and the 3 on a 30, 60, 90 because of the unit circle.
I thought that was also 30, 60, 90, the 3/4 square.
It is not. We just proved it's not. You got to get that out of your head. It is not. I don't know. It's not. It's some crazy angle.
It's okay.
I know. You really want it to be, but it's not.
I know you that.
All right. Evaluate the following. Draw a triangle to describe the situation. Now, we have the inverse of x. No more numbers. So the sine inverse of x. So it's over an imaginary 1. Right? So sine is opposite over hypotenuse. So my hypotenuse is a...
1.
Okay. So to get cosine, I need the adjacent. So, because the hypotenuse is 1, the opposite is x. Here's my theta. So I need this. So I need the square root of 1 squared minus x squared.
X squared minus
So you get the square root of 1 minus x squared, because 1 squared is 1. So your answer is cosine equals adjacent over hypotenuse. So my answer is square root 1 minus x squared.
So that's cosine.
Yes.
That one could have been a lot worse. Like, I bet this next one's going to be awful.
It's not.
That's not awful.
Okay, the tangent is what?
Opposite over adjacent.
So again, no denominator, so it's a 1.
Yeah.
So opposite, adjacent. So what do I need?
Hypotenuse.
So it's like 1 squared plus 3x squared. So again, be careful. It's not 3x squared. It becomes a 9x squared.
And then you put that over the 1.
Yes.
Do 1 over that.
So sine is, no, not 1,
3.
is opposite over hypotenuse. So the opposite is 3x. So the sine is 3x over square root 1 plus 9x squared.
You can't have that.
We're going to leave this down. Because when we get back, when we do inverse derivatives,
Yes.
you're going to see how this answer reflects to that. Because the inverse sine has a square root and it's not.
This is much easier than whatever else we've been doing.
Yeah. I understand this.
Like, the past couple days, I have no clue what I'm doing. This, I know what I'm doing. It doesn't, or it does?
It doesn't really.
So now we're going to get into the calculus.
Oh.
So now we're going to start deriving inverse string functions.
This is what it is.
I'm a lost you left, Spence. You hold my hand. We're going to walk down the aisle of derivatives with inverses.
I was lost on Wednesday. Still trying to catch up.
Michael, yeah, you can hold my hand too.
He's veering to the right and I'm trying to pull him to the left. It's like the Wizard of Oz. Follow the yellow brick road.
I'm going the other way.
Don't follow the brown road. All right. What?
Yellow, brown.
Eyeglasses. Yeah.
Still, I'm not sure I'm still going to follow the yellow road.
Okay.
I'm just.
We're going to kind of relate back to 3-7. Okay. Y equals the inverse sine of x. And the question is, what is the derivative of that? We don't know. We can't automatically just go, oh, I know what the derivative of this is. But we used the technique previously. How do you get rid of an inverse?
You said it equal to itself?
What? Yeah, so like to get rid of an inverse, you take the sine of both sides. Maybe we just can't have Lexi in class anymore. She's a distractor. So to get rid of to get rid of the sine inverse, you take the sine of both sides. Because it's kind of like if you had the 2 and you want to get rid of a 2, you multiply by 1/2 on both sides. So to get rid of an inverse, you multiply by the original of both sides. So this becomes the sine of y equals x. Now you guys can take the derivative of that. I know you can. What's the derivative of sine?
No idea.
I don't like you today, Spencer.
Just.
You still had me lost in 3-7.
What is the derivative of y when we have implicit now? Because we're taking it. Yeah. So you're going to take derivative of y,
So much.
So you need dy dx.
So it's 1 over.
Because we took the derivative of a y, we need dy dx. The derivative of x is
No.
1. We're done with dx dx's because like almost all of you got A's on your implicit quiz, so we move on.
I thought it was really confident that you said it was just 1. So I was going to say dx dx. But
Yeah, we let us see this.
Did I give them back? Oh, you just weren't here that day.
Yeah, I think you did.
I definitely gave them back.
I didn't see what it was. I know what I got, but like I didn't see it.
I did.
Did you give him back one?
Yeah, we weren't
Maybe.
here.
I did. I gave it back when all the boys weren't here. You took it late.
Yeah, because she took hers that day too.
You took it late. Because you stayed and took it into QRT with me.
Oh, yeah, I did come back last time.
But Carmen's the only one who discussed that song.
She's like, I saw it. So dy dx equals 1 over cosine y. Yeah, I put the answer QA and everything. I was like, oh my God. Technically, you saw yours came to see me.
Yeah, but I wanted to see it after.
That's a question.
So we just move that cosine over.
So you have cosine y. Why isn't it cosine dy dx?
Because the dy dx stayed here. I divided both sides by cosine. All right. Hey, do we ever have answers with y in my derivative?
I don't know.
No. We always.
Oh, we know y is equal to inverse sine x.
Perfect. So we got to get rid of the y by plugging in what we know. We don't want our answer to have y in it. dy dx's are always equal to x's. So you got 1 over cosine. Replace the y with its original sine inverse x.
Oh, now you're gonna have.
Oh wait, doesn't this look like what we just did on the page before this?
We didn't do that problem.
Yeah, that's not the one we did.
We
We did a
did
different
one
one.
very similar.
Yes.
We did the
Inverse
same
sine
one,
of
it
x.
just wasn't
Yeah.
over one.
So this one is like x over 1. So now we know my opposite is x. My hypotenuse is 1.
Your adjacent is the square root of 1.
So I got x over 1. So what's my this?
1 minus x squared.
So the cosine of theta is adjacent over hypotenuse.
So it's 1 over.
So this becomes 1 over square root 1 minus x squared.
And that's the door.
That is the derivative of inverse sine, always.
Because I wanted to see that once you prove it once, you don't have to.
So you're going to memorize this, essentially. So the derivative of sine inverse is 1 over the square root of 1 minus x squared. Because you're super smart. Yes.
So does this in any way relate back to the table? Like that table of inverse? Because like it says there, if sine y is equal to f, like if and only if.
It just is going to limit what values you can plug into x. So your x's can only be, and think about it,
Oh, that's
x
okay.
can only live from -1 to 1. If you tried to plug in 5, 1 minus 5 squared is the square root of -24. Can you take the square root of a negative? So that table tells you what values are valid to plug into x. So that's kind of like saying, okay, your domain is -1 to 1, and actually it's not equal to -1 and 1 because you get a 0. And I think is my table up.
Yeah, it has equal to it. That's what I was just
Okay.
asking.
So that's just kind of you having, because this is the derivative of the inverse. It's not just the inverse. This is the derivative of the inverse. So that's why the domain is a little bit even smaller. It can never be bigger. It can always be smaller. Yes?
The cosine of y is equal to arc sine of x.
Yes. Because y is equal to arc sine. From the given. Way back to the beginning. So, we proved sine. You could technically manipulate all of these to prove all of them. That would take a lot of class 10 that I don't want to take. So I'm going to give you the remaining derivatives.
Oh, 5.
However, you need to pay attention to the fact that this original was just an x. So like the derivative of x is 1. So if it was something other than
So like
x,
example
like let's
4.
say x squared, you have to take into account the derivative of the x squared, and that would get taken care of in the numerator. So that's why all of the example derivatives I'm giving you on the next page have a u instead of an x, because u would represent a function. So when you get these, this u can be a function of x, which means it could be x squared, it could be x cubed. So when you have that, you have to put in derivative of whatever this function is in your numerator.
Oh, the tangent one's easy.
So tangent and cotangent are just the sine and cosine of a positive. Yeah. And this
Part of
for
second one is the secants and the cosecants.
the only difference between sine and cosine is a negative. The only difference between secant and cosecant is a negative. And the only difference between tan and cotan is the negative. So just like before, all derivatives of c's are negative. All derivative of inverse c's are negative. Really?
I was-
Were you like daydreaming?
No, I was
What?
just thinking. I'm sorry. I can get.
Just go down the first
That's what
column
I was
because
just
all the
gonna
other one
do.
is the opposites.
I was just thinking there. I'm sorry.
I think I got 4. Probably wrong.
Alright.
Huh? It's just, yeah, it might be. I'm thinking it's 2t errors.
So f of t is equal to the inverse sine of t squared. So your rule is f prime of t is u prime. So in this case, u is t squared. So derivative of u would be, so it's u prime in top, so it'd be 2t over the square root. It's always 1 minus, and then in this case, it's u squared. So exactly, u squared in this case would be t to the 4th, because t squared times t squared is t to the 4th. So it would be 2t all over the square root of 1 minus t to the 4th.
Yeah.
Hmm?
So we're no longer now going to take this like sine of each side because that's the long way to do it.
Correct.
So we're bringing back the u's.
Correct.
Okay.
And you don't have to do the u's. The
Get
u's
ready
just,
for the
I
next one.
think, make it easier.
It's definitely quicker.
Okay. The u is the angle.
Yes.
So in this case, u equals the square root of x minus 1. You need to know 2 things. You need to know u squared and you need to know u prime. So u squared is relatively easy because the squaring of a square root becomes,
Just what's up with the
so the u squared is just x minus 1. The derivative is a little bit messier. So the derivative of a square root is 1/2 x minus 1 to the negative 1/2 times derivative of the inside, but the derivative of x is 1, derivative of negative x is 0. So this simply becomes 1/2 square roots of x minus 1. The reason this becomes problematic is because now I'm going to get a fraction in a fraction when I take my derivative.
The inside is zero. The inside is zero. How-
Derivative of the inside is 1 minus 0, not 0.
It's 1 over 2x.
So derivative of x is 1. Derivative of 1 is 0, so it's 1 minus 0.
Probably wrong.
Okay.
So y prime, or dy dx, will equal u prime, which is 1 over 2 square roots of x minus 1, all over,
That's too much work.
what?
Too much work.
No, it's not. U squared, which is x minus 1, plus 1. So you have,
Thanks.
You bring the X
you're
up.
killing my mojo. Okay, but yes. So you get 1 over 2 square roots of x minus 1, all over x. Anytime you have an x in the denominator or alone, it's kind of like our h. It gets absorbed into the other denominator because you multiply by the reciprocal, which is 1 over x. So you're going to get 1 over 2x square roots of x minus 1.
I'm ready. I'll take this one. Not from last chapter, but I will take this chapter. Like the last section, I'm still no clue what's going on.
Well, that's part of this section.
I'm getting really.
Yeah, this is all 3/8. Inverses is all 3/8.
Yeah, well, 3/7, I didn't know what was going on. Not me. They put me in new banks.
I have a ton of kids that need tutored.
Can you just call her? She has like 25 tutors.
No back.
Yeah, she always has like one day. The past 2 times I've gone, I haven't done had to do anything.
Oh, I need tutors today.
So like, you should call her. And be like, get me in here.
Yeah, I don't have to take this for today.
So you're just gonna cap?
I'm in massage roles, but like I only have one pass for the week, so I'm not gonna get.
I can call Ashmore and see if she'll let you stay here.
She's not here.
I'll
I mean,
call
you're
Jasper.
somewhere.
I'll just call. Yeah, I'll figure it out. All right. Y equals the arctan of 3x.
See that? Why?
Typo. Typo. Sorry. What's the u value? Yeah, I mean it's not a lot. U is equal to
3x.
u prime is equal to
3.
u squared is equal to.
Nice.
Okay, so the derivative dy dx is equal to u prime, which is
3.
all over 1 plus u squared, which is, there's your derivative. I drop. Not really, drop it.
What
When
the
you
heck?
just know the little equation you just plug in.
It doesn't want the inverse, it just wants the derivative. Can't you just go side by side and do it that way? Or no?
He spoke gibberish.
Right
Alright.
now, I'm at 3 over secant y squared.
Well, why would you do it that way? Because that's just gross.
He's just trying to find it.
All right. Every once in a while, you have to know your identities, and we've been talking about them, but like I haven't given them to you in a while. It's just kind of something to throw back at you. We may or may not need them. Oftentimes, you can manipulate the equations as not to have to use them, but I want you to have them. Just
3 over 1 plus 9x squared.
1
You're really trying to figure it out by doing implicit. No, please don't say that, because you actually got an A on that test.
Wait, that was implicit?
Yes.
Don't worry, my mom said it too.
I don't even know what that word means.
The racing. I don't think this case.
Cool. And then you go finish the sentence. So it's 3 over 1 plus 9x squared. Because you got your Pythagorean identity.
Yep, so it would be hypotenuse over adjacent.
That was too much work in my opinion.
You don't have to do it this way!
Wait, no.
Oh dear. I thought you were doing it just to be a pain.
He's calling you out.
I did my Pythagorean identity because, whatever the heck, secant plus is whatever is equal to 1. So it's 1 plus 9x squared.
Oh.
So it's 3 over 1 plus 9x squared.
Yeah.
That's just too much work.
That's why there's a formula that you can memorize. But, like, let's say you get to the AP test and you're like, oh my god, I didn't memorize my formula! You can do it by hand, is the point of all of that. Like, do you see what I'm saying?
Yeah.
Like, if you get to the AP test, you're like, oh my gosh! And you, like, freeze up. Technically, you could do it by hand. But you didn't have to for the example we just did. Because you have a formula.
I know.
Okay.
I saw the derivative.